And the topic today I want to talk is, I think it is an extended version of Introduction to Simulating with Applications. I did read something in the book for simulating usage, and it's only a section. And simulating is quite useful in many engineering fields, especially in control fields. So I think it is better for me to give a detailed, extended introduction to this topic. And the contents I want to talk today include a very brief introduction, historical review, and very basics of simulating. And then we should talk something about how to use simulating to solve ordinary differential equations. And then I will give a few examples on how to solve the problems in control, how to simulate control systems, different kind of control systems. And then I will talk about engineering system simulation, including electrical, electronics, mechanical, and other physical things. Also, I need to give an introduction to video processing part of it. And then I will talk about how to display simulation results. That is, we can use scopes, and apart from that, we can use gauges, and we can even use virtual reality kind of thing to visualize simulation results. And then I will list some of the advanced topics in simulating for your further study. Simulating, I think you are quite familiar with simulating already, is a block diagram-based solution for problems. You can use blocks to connect your own system and then perform simulation of that system. Before the appearance of simulating, there is a very famous language called ACSL. We have to use commands to represent the complicated systems, but it is quite complicated. And after simulating, the appearance of simulating, I think ACSL is no longer so popular. Most of people switch to simulating instead of low-level programming. Simulating appeared first in 1990s as part of the Matlab program. The original name then was called Simulab, and the name is quite similar to the very famous software called Simulab. So it changed its name in 1992, I think. The name simulating has two meanings. One is simu for simulation. The other one is link, which enables you to link block diagrams. So it is quite useful in modeling from a block diagram-based description of systems. And for control systems, if we use simulating, we can easily compose a control system structure rather than use the low-level commands. If you use low-level commands, normally it is restricted to linear systems. For non-linear systems, this kind of thing will not work. So for control, simulating is a quite good tool to model systems and to simulate, to perform simulation of systems. So under Matlab window, we can type open system command like this, or we can click this icon to start simulating. And the results of the two are slightly different. One is with a model browser, the other one is a window-based thing. So we can start simulating in this way. I think most of you have already an idea what simulating is, so I just show you some of the important blocks we want to describe and we want to use. If you start simulating, you will have window like this, a library window like this, where you can see that there are sources group which are used for input signals. And then this one is used for output signals. You can display the message. You can display the graphs and other things with this terminal, with these blocks. And you can model continuous linear systems, discrete linear systems, and those ones for non-linearities. And there are quite a lot of important blocks in this group or in the library. Also, there is an extension to ordinary Simulink because there are so many toolboxes in Matlab, and there are some compatible versions of block diagram things which are called block sets. And from the block set you may see that there are quite a lot of blocks like this for different toolboxes. So this is a very brief introduction to Simulink, how to start it. Now let's have a further look at the blocks. We have sources blocks, which are usually used for input signals. We have step input, sign input, pulse input, and other input signals. Also, there is a very important one called import, which is usually used to indicate input signals. And there are different kinds of inputs from this group. And if you have created a simulation block diagram, you want to display the signal, then you can use a block in this group. And in this group, we can see that you can connect a scope to the signal. And also we can have a text display, value display of the signal. And also we can write the signal back to Matlab environment. And also we have a very important one corresponding to the import. There is the output, allow you to indicate the output of the system. And in this group we have linear transfer functions, space descriptions, and zero-pole gain description to systems. And also we can describe easily the time delays. We have a constant time delay, and also we can have a variable delay. If you are using a variable delay, then it is easy to model, for instance, network control systems, because the delay is usually random, so we can assign a random signal to describe the delay time, and then it should be a random delay generated. This is useful for network control systems. And for the discrete version of that group include items like this, the transfer functions, filters, state-space equations, state-space expressions, and delays. So we have similar things. Also, for discrete time systems, we have zero-order holds and first-order holds. And also we can have a non-linear block, for instance, saturation, which are useful in model control if the system has an actuator saturation. And we have a dead zone and other non-linearities. Apart from this, we can easily establish our own non-linearities. And we can have mathematics operations on signals. For instance, you can add two signals together, or you can subtract one signal from the other. For instance,